Now, before we get started, are there any questions on any of the assignments thus far? Feel pretty comfortable with the homework so far? Let theta be an angle. So what we're looking at today, before I just dive right into a definition, we're looking at trigonometry, the sine, cosine, tangent, secant, cosecant, cotangent of any angle. And most likely what we're going to be given is a point somewhere on the xy coordinate plane. And we're going to be asked to find an angle and these values. Now, let theta be an angle in the standard position with xy. Standard position just says that its starting point is the positive x-axis, and it's somewhere around the circle going clockwise. With xy on a point on the terminal side of theta and r is equal to the square root of x squared plus y squared. And it's not going to be equal to 0, because if it's equal to 0, it means it's the origin, is what it is. Now, this here makes sense. You don't have to write this part down. But if we dropped a line straight down to make a right angle, the distance of, well, I say blue, but it says not, from the origin to this point here would be the distance of x, whatever the x value is. And the distance from here to here would be the y. And the hypotenuse for us would be r. So what we're saying is our a squared part is x squared, plus our b squared part is y squared, is equal to the radius squared. And if I square root both sides, we get the radius equal to the square root of x squared plus y squared. We don't put the plus or minus because we're talking about a distance, a length, and a distance is always going to be positive. So that's really where we get r is equal to the square root of x squared plus y squared. And we do have these here. Sine of theta is equal to y over r. Cosine theta is equal to x over r. Sine theta is equal to x over r. Tangent of theta is equal to y over x. Cotangent of theta is equal to x over y. And secant of theta is r over x, and cosecant of theta is r over y. Now, you could write these here onto your unit circle if you want, or kind of go based off a triangle. Because we could do this in one of two ways. One of them is that we constantly look back. So negative 3, 4, sine of theta is y over r. Cosine of theta is x over r. And continue to reference these here, which is not wrong. That's the correct way to do it. We would just have to find the value of r. One way I find it nice, or find these, or how I solve most of these here, is not so much focused on those, is I draw a coordinate plane. I don't try to make the coordinate plane to scale, but I draw the coordinate plane. And I look at the point, negative 3, 4. So we're negative 3 on the x, 4 on the y. And I make my triangle, because this is where this point is located. And it's telling me the x distance is negative 3, the y distance is 4, and we need to find the hypotenuse. Does anybody have a guess at what the hypotenuse is? 5. Because this is a 3, 4, 5 right triangle. So we have that. Yeah. Been a little off. have 3, 4, 5. So we have this here. Now sine of theta, because we can think of it in terms of y over r. Well, the y value is 4, the r value is 5, so we have 4 over 5. Or I can look at that triangle and see that the opposite side of our angle, this angle here is 4, the hypotenuse is 5, we have 4 over 5. Cosine of theta. Again, we can reference our x over r. The x value is -3. The r value is 5, so we have -3 over 5. And lastly, tangent of theta, according to our formulas here, is y over x, 4 over -3, opposite over adjacent, 4 over -3. We get these here. It didn't ask for it, but cosecant would be 4. Secant of theta is -5 over 3. And cotangent of theta is negative. Yeah. Yeah, so -4 or -4 over 3 for tangent's the same as 4 over -3. They're the same. It's just the placement of the negative. I have a habit of putting it with the numerator. I just didn't do it on the first one. Questions on this here? Now you have both of these here. For our quadrant 1, the angle is between 0 and pi over 2. Or if we wanted it in degrees, it'd be 0 and 90. Second quadrant is going to be between 90 and 180. Third quadrant is between 180 and 270. And the last one's between 270 and 360. And it kind of lists out which, well, in the first quadrant, x and y are both positive. Second quadrant, x is negative, y is positive. Third quadrant, both are negative. In the fourth quadrant, x is positive, y is negative. So we have these here. And we've already gone through which one's positive, which one's negative with sine, cosine, tangent. And then it also holds true with secant, cosecant, cotangent. Because if sine's positive, cosecant's positive. If cosine's positive, secant's positive. And vice versa. So not a lot of new information there. Let -9, -12 be a point on the terminal side of theta. So again, we could use x, y. I have a tendency to stick to plotting the point because we have negative, well, I'm going in the wrong spot. Because since they're both negative, we are in the third quadrant, -9, -12. X distance is -9, or y distance is -12. Which tells us, well, we need to find the hypotenuse. Anybody have a guess of what the hypotenuse is? It is 15. Because we can do it in the formula, -9 squared plus -12 squared. -9 squared is 81. 12 squared is 144. 5, 225, which is 15. Now the hypotenuse will always be positive because the hypotenuse is r value is a distance, so it's going to be positive. And it is 15 because 9 and 12 are multiples of 3 and 4. Well, 3 times 3 is 9, 3 times 4 is 12, and 5 times 3 is 15. All right. I need to fix that later. Because the previous problem was the one we did earlier was -3,4. I covered it up, and then when I erased all ink on the page, it uncovered it. So I just need to make sure to lock it in place. So our sine of theta. For this one here, well, opposite side is -12. The hypotenuse is 15. Well, there's a common factor of cosine of theta. Our adjacent side is -9 over 15, which is -3 over 5. And tangent of theta is -12 over -9. Now there is a common factor of 3, which would give us 4 on top, 3 on bottom, but the negative and negative make a positive. So it still lines up because we were told in the third quadrant, sine and cosine are both negative and tangent is positive. If we found cosecant, it'd be -5 over 4. Secant is -5 over 3. And cotangent is 3 over 4. Because really, once we find sine, cosine, tangent, we have secant, cotangent. The only thing we really have to deal with is the simplifying the radical if there ends up being one in the bottom of the fraction. Otherwise, they're pretty nice. Values of the trig functions of angles greater than 90 or less than 0 can be determined from the values at a corresponding acute angle called reference angles. Definition of reference angles. I don't know. Apparently they decided to have that because I took this straight from the book. Let theta be an angle in standard position. If reference angle, its reference angle is the acute angle theta prime formed by the terminal side of theta and the horizontal axis. So, yeah, I don't know why they put those there, but okay. Now, a reference angle is always going to be between 0 and 90. 0 and 90 degrees. So, less than theta is less than 90. Or we're going to say it's between 0 and pi over 2. Now, they only listed 3 quadrants. 1, 2, 3, or 2, 3, 4. They didn't list 1 because first quadrant is between 0 and 90, 0 and pi over 2. So whatever angle they give us in that first quadrant is the reference angle itself. There's no need to change it. Now the others in quadrant 2, here is 180 or pi. So whatever angle they give us, this theta value, we're going to subtract it from pi. We're going to subtract it from 180 to get what they call theta prime, this angle here. Because those two angles, theta prime and theta, are what we call supplementary angles. They add together to be 180. So we subtracted from pi or 180 to find the reference angle. If it's greater than pi, it's greater than 180. Then we subtract that angle, or subtract pi or 180 from that angle. Does that make sense? Or if it's greater than 3 pi over 2, or 270, then we subtract it from 360 or 2 pi. And there are some differences, and it kind of works out in the end. So for these three here, 300, 2.3, and negative 135 degrees, we want to find each of their reference angles. Now the first one, 300 degrees. If we think of it on the units, or on our coordinate plane, 300 degrees is going to be down here, because straight down is 270. So to find the reference angle, we're trying to find this piece here. So what we're going to do is we're going to take 360 and subtract our angle from it. Because we're trying to see how far, or what is this angle here. And if we do this here, we get, so our theta prime, our reference angle, is 60 degrees. That's it. .3 is that a degree measure? Yes. It's a radian because, one, it doesn't have a degree, and most likely it's going to be a radian. Well, because it's nothing listed there. Now, pi over 2, 2 pi over 3, or 0 or 2 pi. We got to figure out where this lands, because so we can figure out which quadrant we're in. Now, it'll be good to know what pi over 2 is. It's not going to like having it there as a decimal. Is this here? Is the angle they gave us bigger than this number here? Okay. So we have that. So we know that 2.3 is bigger than our pi over 2. Pi, for the most part, we know the first 3 digits, 3.14. Okay, it's definitely less than that. Yes. So our angle 2.3 is somewhere right here. So that means to find it, we're going to take pi and subtract 2.3 from it to get our angle. So this one here, we can grab a calculator, say pi minus 2.3, we're going to have to round. 0.84. So our theta prime for this here is 0.84. Questions on this here? Now the last one, C. Zero. Now this time we have negative 135 degrees, yes? So we're going clockwise. Well, this here is still going to be 180, but instead of positive 180, it is straight down is negative 90, and straight up is negative 270. Because the negative, any of the axes, the positive y, the negative x, the negative y, positive x, we're just, to go from 1 to the next, we're just adding 90. Or subtracting, so 0, negative 90, negative 180, negative 270, negative 360. So if we're going this way, negative 135 degrees, well, we'll definitely pass up negative 90. We're not going to get past negative 180, so it's down here in the third quadrant, yes? And this one is where it gets a little tricky. Because we don't want to know this angle here. We don't want to know that whole angle. What we want is just this little piece. We're wanting to know the difference between what our 180, negative 180, negative 135, yes? So what am I doing? I'm taking $135 away from, which is, so our theta prime in this case is 45 degrees. It actually won't. And that needs a degree marker. Because if we look back at reference angle, so the value of a trigonometric function of an angle greater than 90 or less than can be determined by a reference angle. So the acute angle theta formed by the terminal side of an angle in the horizontal axis. So where the angle finishes on the angle of the x-axis is what we're looking for. And it's always going to be acute, so it's going to be positive. It's going to be a positive angle. Does that make sense? It's a little weird because really the other way to go about this is I would take negative 135 and add it to 360, which would give us 225 degrees, which would be the angle going the other way. Then we would take that 225, subtract 180 from it, and get 45 degrees, which is our reference angle. Because all of our reference angles will be between 0 and 90, or 0 and pi over 2. Does that make sense? So instead of finding the other side of it, the other coterminal angle, then finding the reference angle, we just went to the reference angle. Because we saw what two spots were kind of going between and found the measure. Does that make sense? Yeah. Any questions on any of this here? All right. Now the ones before we really didn't need the coordinate point, but here we will. These is going to be definitely helpful to graph out which quadrant we're in. So they told us the value of tangent. Tangent of theta is equal to 15 over 8, opposite over adjacent. Now that's fine and all, but there are two quadrants for which tangent is positive. One of them is the first quadrant, the other is the third. So we don't know which quadrant we have, so there are two different setups we can have. And for the most part, you're thinking, well, that just means sine and cosine are going to have the same values. Well, yes. But in the third quadrant, sine and cosine would be negative. And the first quadrant, sine and cosine will be positive. So that's why they provide this second part. They tell us sine of theta is greater than 0. Sine of theta is positive. So what that means for us is our triangle is over here in the first quadrant. Now, that's neither here nor there, but it does tell us and help us with signs. That's the reason I do this. Because tangent of theta, tangent of this angle, is 15 over 8, opposite over adjacent. Now, 8 and 15 are not one of the reference angles we normally pick, or not normally pick, but not one of our trigonometric identities. Actually, I'm going to have to Goldilocks this a little bit. Not trigonometric identities. It's our Pythagorean triplets. So it's telling us our hypotenuse is equal to the square root of 15 squared plus 8 squared. 15 squared is 225. 8 squared is 64. So we're saying our R value is the square root of 289, which is 17. So it is a Pythagorean triple, it's just not one that I know off the top of my head. 8, 15, 17. So we get this here. So to find all 6 trig values, well, really we're not finding all 6, we're finding 5 because they gave us 1. So sine of this similar angle, the opposite side is 15, the hypotenuse is 17. Cosine of theta, adjacent side is 8, hypotenuse is 17. We don't have to do tangent, but cosecant of theta, 17 over 15. Secant of theta is 17 over 8. And lastly, cotangent of theta is 8 over 15. Questions on this here? Questions on any of this here so far? We're ready for the next one. Find the exact value of all 6 trig functions. Theta lies in quadrant 2. Okay, so we're over here. Theta. That's just our reference angle. Sine of theta equals 0.6. Well, I'm going to tell the calculator, convert this to a fraction. Because, I mean, we could have done that also, because we could have put it as 6/10, then reduced to 3/5. So it's saying sine of theta is 3/5. We could have done this on the last one, but we didn't. What's cosecant of theta? Yeah. Because on the last one, they gave us tangent, so I automatically know cotangent, yes? Because cotangent is just 1 over tangent. We flip it. So since I know sine, I imaginally know cosecant. But we still need cosine of theta and tangent of theta, as well as secant of theta and cotangent. I mean, we have most of it. Cosine, the denominator is going to be 5, because sine is opposite over the hypotenuse, yes? Well, 4, the other side's 4, yes? And this is where I like setting these up, because it's going to be very tempting to come over here and say cosine of theta is 4 over 5. Secant is 5 over 4. Tangents, 3 over 4, and cotangents 4 over 3, yes? And that's not completely wrong, but it's also not completely correct. Because look at the value 4. Which axis of x is it on? It's on the negative, which means this is negative 4. Because if we plugged it in, used quadratic, or the Pythagorean theorem, and said 3 squared plus b squared equals, well, it should be 3 squared plus our y value squared equals r squared. Well, not r squared, 5 squared. Well, 3 squared is 9. 5. It's going to be very easy to just say y's for it. Well, actually. Oh. Today, Monday? Should be x, because we're on the x-axis. Variable's not hugely important, but we get 4, and we normally leave it as positive 4 and move on. But because we're on that negative axis, we have to take the negative account, the plus or minus. Does that make sense? That's part of the reason why I do this here, because it does take that into account so that we're not having to constantly check ourselves. And it's an easy way to check because negative x-axis, we know that, we can see it, so it means these are all negative. Makes sense? That's why I like that, because it helps me keep track of our positive and negative values. Especially if they give us tangent in the 3rd quadrant, the value of tangent, the opposite and adjacent side are both going to look positive, but they're actually both negative, because we're in the negative x and negative y. But a negative divided by a negative is a positive, so they don't show up for tangent. It's just more ways to check and make sure we got the correct signs, because as you've learned over the years, there's nothing that will mess up a problem more than either A, forgetting a sign, or B, misplacing a negative somewhere, or adding one that you don't need. Throws everything off. I did give these to you here. These are common trigonometric angles. 0, 30, 45, 60. That's the whole basis of the unit circle. They're just reference angles for 0 or 30, 45, 60 all the way around. 90, 180, 270. 90 straight up, 180 is our negative x side, 270 is straight down, and then when we get back to 0, we're straight back over, our positive x. And really, most of what we do ends up revolving around these here, or at least if we can try to, that's where we end up falling. Because if you're working with most slopes, a ramp, most ramps, if you're trying to decrease the work or you're trying to pull something up, I believe they normally hover at about 45. If the TV show The Big Bang Theory is correct, and I believe they are, a 45-degree angle decreases the amount of work by half. You need half of the amount of force to pull something up a 45-degree inclined plane. So 45 is helpful. These angles are helpful. Questions on this here? Now, we're going to stop for today. We will finish this tomorrow.